So, thanks for the introduction. How can we apply machine learning to increase joy? That's the main question that in this case study I'm going to explain to you, we try to tackle. I work at Rovio, a mobile gaming company, the creator of Angry Birds. I guess most of you have heard about them. At Rovio, and in mobile gaming companies in general, it's not enough anymore to just ship a good game. You need to kind of keep improving and keep adding content to the game to keep making it better and to keep the players engaged. That's what we call live operations. So how can machine learning help with that? Machine learning can help to kind of deliver the right content to the players so they will enjoy it the most. So sometimes this is also done with rules or heuristics, but machine learning can also help with that. Let's put you an example. Some player can be playing like Angry Birds Dream Blast, one of our games, and he may be stuck in a level. They may be playing for several days and being in the same level, and then they get frustrated and they quit the game. So with machine learning, we can detect when they are being stuck, and then the games can give them some help. So that way we can apply machine learning to improve the game experience of our players. Let me first start talking about our cloud service platform, because I work as part of the technology team, and we have a beacon platform, that's how we call it, and that's all our games use it to run their live operations across other things. So we provide a lot of services to the game teams, and across those services, it's ML. So we wanted to, as part of this project, to integrate our ML product as part of our beacon platform that the games were already using. Traditionally, games have tested different use cases with A/B testing. So if we go back to the previous example, we would have, like, for example, one game variant, A, where we would give some help to players that are stuck. Then we would also have like another variant B, where players wouldn't get any help. Then we wait for a certain amount of time and observe like which variant has better impact in the players, which ones enjoy the most. And based on that, we pick that variant and we ship it globally to all the players. So then by doing that, we just pick the right variant for most of the players, but this is not most of the times the global optimal variant, because some players might be enjoying also like this kind of challenge of being stuck. So those players, when they receive help, they will enjoy the game less. And as opposed to that, we are proposing a different way of doing things where using beacon personalized rules, you can have like both of the variants, giving help or not giving help, A and B, together at the same time live. And in that way, doing that, we can personalize the gaming experience for different players, so we don't need to just ship the global optimal variant. And this is basically the main idea behind it, that we want to optimize any aspect of our games at the level of individual players. And the end goal is that to increase the player satisfaction, and how we track them kind of like if they are happy or not is like we have different business metrics. Depending on the use case, sometimes you want to track engagement, and it depends on the use case. But so we want to make also that flexible, like the kind of business KPI you want to track for testing these things. And how it works, so in this case, we have like one game, and I'm playing the game, and then the game client asks which game variant do I want to show this player? And then the recommender answers, so let's make the level a bit easier because it's been stuck for 3 days. And then after some time, this depends on the use case. Sometimes the rewards, you need to wait a couple of days to observe the reward. Sometimes other use cases are more instant rewards. But then like the reward comes back to the learner, and then the learner also gets the recommendation, the player context, information about the player, and then it improves the recommendation strategy. So this is what is going behind. And the kind of technology behind these things, so for the recommender, we have AWS SageMaker with custom Python containers. And then like for the learner, we have like our workflow manager is Azkaban, an open source project by LinkedIn, and that we use for scheduling EMR jobs in PySpark, but also like we do kind of schedule the model trainings. So then the model training then kind of updates the real-time serving endpoint in SageMaker. So here I will show you a video about how this looks for the game team. So they can go in this website, create a new rule, a personalized rule, and then they can add here like the different child rules that are the variants, the different things they want to personalize. They pick a business metric, in this case retention, for example. Then they can select the features they want to put into the model. So in this case, let's say we are focusing engagement. So let's pick like the days accessed recently, like the minutes that the player has played, like the sessions that the player have played. I mean, and then they have the freedom to select. Then we have like a standard features for all the games, and other features that are maybe like they can send and they are specific for the game in real time. We can also pick criteria. We only want to personalize in Canada, for example. So we can select that. And we can select this, like how often do we change the recommendation for a player, in this case, 3 days. And then like the game teams like go into each of these children and then define the kind of the behavior that the player is going to get. So in the first rule, it will be no help, for example, like continuing with the example I started before. In the second rule, it will be like helping the player, like maybe showing an ad to the player where they will give some power up in the level. So it's like we will show an ad we can define the frequency, one ad every 10 hours, for example. And then with this ad, it will be a video reward that they will get help. But then there are other ways to help the player. So maybe let's help the player also without an ad. So we can define JSONs. These JSONs go into the game client. So the games can use whatever JSONs they want. And this JSON will be fed into the kind of a game feature that will make the game easier for the players without them needing to watch an ad. So then we can put this live, and then this kind of rule the model will decide which for the player, which kind of these options it will be shown to the player, and then it will learn with time to improve and to optimize towards retention. That was the business metric we picked. So I'm going to kind of refresh a bit some concepts about reinforcement learning, because we use 2 types of reinforcement learning, contextual bandits and deep reinforcement learning. So in reinforcement learning, you have an environment, and the environment usually, like in our case, is kind of like the players playing the game, and then the environment sends a state to the agent. The state will be information about the players, like is he stuck or not? Where is he from? Things like that. Then the agent picks an action, so it would be the recommendation. And then based on that, then after some time, we observe a reward associated with that action. And that's how we construct our training set. Then in deep reinforcement learning, the only difference is how we observe the rewards, because we kind of concatenate them in a sequence of actions. So in order to explain that, let's see in this example, we have like a player. I kind of log in the game, play 1 game session, and I get a recommendation from a contextual bandit. And then I log in tomorrow, another game session, then I get a different recommendation. But in the training of the model, each decision is made in isolation. But in deep reinforcement learning, like these kind of decisions are tied together. So there's a sequence of actions that the model learns from. So that's kind of the key difference. And this is another way to look at it. So it's like the main thing is that you have a state, action, reward, next state, next action as training set, where in contextual bandits, you don't have that. And so it's like you can see that for some use cases, contextual bandits can be good enough because the use cases are simple, for example, conversion use cases. But for other behavior, like you want to kind of track how the player evolves, like across several days, and you want to have this kind of sequence of actions together. So in that case, you want to use deep reinforcement learning to capture the extra complexity of your use case. And what do we use for this? So for contextual bandit, we use Ballpark Wabbit. It was developed by Yahoo, open source, like a command line tool. And right now it's kind of maintained by Microsoft Research. And for deep reinforcement learning, we coded the models in PyTorch. Ballpark Wabbit is really powerful, but the problem is that it has so many kind of options, and sometimes you get lost. So the good news is that you have official docs, and the community is really helpful. So you can put like issues in GitHub. You can also like chat with the developers and the maintainers, and they really help you out. But we have like these 2 options: epsilon greedy exploration, and we have as an approach of the CB type in Ballpark Wabbit means the off-policy evaluation is doubly robust, the one we use. And for PyTorch and deep reinforcement learning, we evaluated like a lot of different papers. All of them are based on DQN, Deep Q Network. And then as part of this project, we kind of evaluated all these different papers to try to see which one works better for our use case. And just in case you don't know, like for reinforcement learning, if you are not familiar with it, you can start with this OpenAI Gym project. It's really good. This is kind of the typical example, carpool, and the goal is to keep the kind of the pole up. So you have 2 actions: move right, move left. And then the good thing about these environments that you can find in OpenAI Gym is that they are easy, so you know if you have beaten them or not. So in this case, if you have the pole up for like a specific number of seconds, then you know that your model is working. And when we were looking at all these papers, sometimes you change something, because I mean, sometimes they open source the code, but sometimes you want to combine several papers. So if you break something and it doesn't work in these easy simulators, you know something's wrong. So it's kind of like, for testing your models, it's good to start simple. And how do we approach this project? So we divided the project in 4 main phases. The first one is research, because as you saw, we had to read papers. We had to see what's going on in the state-of-the-art field in reinforcement learning. There are not so many productionized blog posts out there about these use cases. So it's not that easy to find what to do. And then the second part would be the engineering part, like pipelines, model serving, all that side. Then the integration, that part in some projects is optional, but in this case, because we wanted to have as part of our own ML platform, then we wanted this to be kind of self-service for the game teams, so that's why we needed to add this integration phase. And the fourth step is rollout, that some people sometimes ignore the rollout, but I mean, we treat this as ML as a product, and then you give the product out there, and you need to kind of work with the customer how to use the product correctly, how they can get most of the value from your product. So it's important, and sometimes takes more time than is expected, because it's hard for the people to understand these complex models for the use cases. And let's talk first about research. So research, when you say research, you think about messy notebooks, about like lots of people doing different things and disconnected, and sometimes it's like that, but what I say is it doesn't need to be that way. I mean, if you start the project, I mean, collaborating, I mean, in our case, machine learning engineers with like data scientists, and you work together with data engineers, then you can set up a common, since day one, a common structure, like set up the common project structure folders, proper dependency management. In our case, we use Poetry, like a proper CI pipeline that's like that it works out of the box. In our case, it's GitHub, GTeam City, but each company has their own. And then for testing, always try to start with unit test, PyTest, for example. Of course, at the beginning, the research phase, there's not so many unit tests, but when you start to define what you're gonna really do, then you start putting more and more unit tests. And then linting, we also use these kind of tools, PyLint, Flake8, MyPy, Black. So I think it's kind of the usual tools that to kind of try to keep the code a bit unified, readable, and to be working nicely with all these notebooks early on. So the earlier you do these things, the easier it will be afterwards to productionize the project. And then it's not only about the tooling, it's also about how you structure the code early on. So in our case, we created like these different abstract classes in the code. So then like when you are doing research, you just need to kind of follow the kind of methods from your abstract class, and then you kind of abstract all the complexity. So you can try different papers if you follow the recommended abstract class in Python. So then each person can try different paper, can try to implement different algorithms, but they are following the same kind of way of interacting with the environment, the same way to interact with the rewards and with the evaluation method. So each of these different boxes kind of allow us a lot of flexibility to test new things while following the same kind of interface. So here we see in the environments we have Cardpole, that's the one I showed you before, but we also implemented our own Rovio environments to simulate like a bit kind of how players could interact with this. Also we have rewards, so retention, LTV is lifetime value in the gaming businesses. And those are in PySpark code. And then the evaluation methods, that I will talk a bit more later, but testing reinforcement learning is hard. And you don't have like training evaluation test set. Because when you recommend something, you only observe one reward, but you don't know what would have happened if you had recommended something else. So that's why these kind of methods that are called off-policy evaluation methods, they try to help with that. IPS is called inverse propensity score. It's kind of the simple one, but then also like we use doubly robust, that is kind of an improvement over IPS. And then during research, like we need to kind of run like a lot of experiments in parallel. So we use, I mean, I know this is kind of hot topic, but we do use notebooks with papermill in production. So we schedule the notebooks, and I think it's fine as long as you keep most of the code out of the notebook and you kind of follow good practices. It has some advantages because I think that it kind of allows you to kind of, once a model is in production, to iterate over the model, but of course it has its drawbacks too. But we schedule the notebooks with papermill using AWS Batch, so we just run them in parallel to run experiments without having to run them in your local machine. And then we log the results in AWS RDS. We could use MLflow or some other tracking tooling out there. We don't have any at the moment, but for us it has worked just to log things in RDS and compare the results for this project specifically. And then it comes the engineering. I won't go here in much detail, but then once you have like the kind of the experiment that really worked the best. The good thing is that we already had that in Docker and in Python, so it's just the stat box from the research, you put it in the engineering. So of course, with some changes, there's never that easy, but you can reuse the code in your Docker container, and then you can create a pipeline, like training pipeline. You first do the PySpark code to train the data, do the daily training, we do the model update in SageMaker, and then some model understanding. And by model understanding, I mean you kind of log metrics for monitoring the models, for tracking some metrics, because then we create dashboards out of that to check a bit what the model is doing out there. And finally, we have the integration. So we also need to do extra changes, like to Java services, like front-end work, like dashboards for data analysis involved there too. Then alerts. By alerts, I mean, for example, Grafana dashboard for the services for the endpoints. Then we also have like a feature store, because the user has to select the features the model is going to use. So all these things need to be taken into account. Also the automation, when I showed you before the video of creating a personalized rule, that's triggering on the back of a training. So all this kind of training flow is being created automatically without user intervention. So then, of course, if something goes wrong by the monitoring, then someone can go there and tweak the models if it's needed. But everything works without like our team intervention, unless there's something wrong and we get alerted by it. And finally, it goes the rollout. So we work very closely with game teams to try to help them, because this tool gives them the help to kind of try to personalize the different options for the players. But what can they personalize? That's a hard question. I mean, there are lots of things you can do in the games, and some of them make sense, some of them don't make sense, and it's just sometimes trial and error. And then we have worked with 5 of our games, and we have done more than 20 A/B tests. So how we usually do these things is we don't just put this in production. We just A/B test these personalized rules using reinforcement learning versus the baseline, and sometimes we compare it against heuristics and rule-based systems. And sometimes I have to tell that some rule-based that the game teams have are really good. They have been working in the industry for a long time, so they have really good heuristics. So sometimes it's very hard to beat heuristics. And even if we beat the heuristic for a really small percentage, it doesn't make sense to take into production because it adds extra complexity. So there's a lot of things that need to be taken into account when we want to roll out new use cases. And I can show you, before I showed you a video from the development environment, but this is how it looks, for example, for our games. So these are kind of main dashboard, and this is Dream Blast game, one of our games. And here is one A/B test we ran recently. So we compared giving help or no giving help versus the control, that is basically the game baseline. And then we have access to dashboard, like these are the A/B test dashboard to check in which kind of KPIs we have lift or not. And we can kind of track, in this case, we have 0.5% total revenue lift in this use case. And we also have, but we did have like some other metrics also varying. So there's lots of things to look at. And then here is dashboard only for the model. So we have like model performance, like feature importance and things like that. And the most important ones though are the kind of the prediction. So what's the model predicting at each time? So here we can get an idea of what is the model predicting at different moments of the project. And you get those kind of like almost real time. So the game team sometimes just ping us and say, okay, this model starts to recommend all the time, no help, is something wrong, and then we can jump in there and help them figure it out, or maybe we can tune hyperparameters, but by default, everything is automated until something weird happens. And what challenges we have faced in this project? So we have faced like many challenges. One area of challenges are in the modeling. So testing, I mentioned before, testing is hard because you don't have like a test set. And I prefer to work with supervised use cases because then you have a test set and you know what you are playing against. And you know, like this is working. But with these reinforcement learning models, you don't know. I mean, you don't know what players are going to do. I mean, sometimes you don't even have data about new use cases. The game has an idea, implements a new feature in the game. You don't even have history data about that thing you want to test. So how do you do that? So sometimes, I mean, it runs in production. So the model will start exploring in production, and sometimes it works, sometimes it doesn't work. But that's why it's very important to have this kind of off-policy evaluation metrics and the simulators, because then you know that it works in kind of the simple games, the simple simulators, and then you know that your code works, and then you know in which parts of the areas you can debug your model in. Then we have reward engineering. That's a very hard topic, and I don't have the answers how to do that properly. I mean, we have some. It's very hard because, for example, a player in the card poll example before, there's a game over. If the poll falls down, you lose. But then with players, like a player can go on vacation for a week. Does that mean that that's a negative reward because he has left the game? Maybe not. So how do you define negative reward? Like if he leaves for a year, for 1 week, like that's one problem. And then the other problem is that you cannot pick like very long time for getting the reward, because although games want to optimize toward long-term retention, long-term value, then the rewards need to be like in days. So you need to pick some reward that is correlated with the long-term value of the players. That's very hard. And then you have like this other problem that is called batch training. I call it like that. But the problem with batch training is that in the simulators, you work in an online setting. So you usually work in episodes. So then it's kind of like from the start until you either win or lose. And then you kind of make a recommendation, and you get a reward from that recommendation online. And then you get the next one, and you get the next reward. And everything goes like online mode. And the model is learning all the time online. But in our use case, I mean, we just get, for example, we have a recommendation for some days, and then the next day we have recommendation only for 1 day, but we cannot replay the player for a year. I mean, we don't know what they're going to do in next year, right? So we just need to work with kind of like the limited set of data without being able to access the full future. And currently in research, in most of the cases, you find these kind of simulators where you have access to replaying the whole episodes. So that's tricky. And then the convergence I already mentioned, sometimes the use case converges, sometimes they don't, so it's hard, and the good monitoring is key there. And then the input data, it's a problem, I guess, in all ML players. Sometimes the data can be dirty. The good news is that we have standard data for our games, so that data, we have like proper data engineers who have proper data quality monitoring, so we ensure that data is clean, but we also provide the games the option to send real-time events. And those real-time events are sent from the game clients, so they don't go through our data engineering kind of pipelines. So then those, of course, can be a bit more messier. And then there's also like other things, like the player can be playing in the subway. The players can play the game offline. So in that sense, you cannot send the value, it will be null. So those kind of cases are hard also. Then the other area that we had problems is the engineering side. So data engineering, like this whole sequence of actions I talked about before, like to concatenate like the action, reward, next action, next reward, that's kind of tricky also. I mean, we underrated how much time it's gonna take us to put all that logic in PySpark, because there are so many different things that can change, and to make it flexible for the game teams, like for example, to make them able to change the duration, that is how often do you make the recommendation. So you can make the recommendation every day, or like every 4 days. That's up to them, but that kind of adds a lot of complexity into the PySpark code in the data engineering. Then we have the real-time inference. So as I said, players can be playing in the subway. So in that sense, the SageMaker endpoint won't reply to them anything. So I mean, by default, we use just random exploration. So we just pick one option randomly. But of course, those are issues then it will kind of impact the performance of our model in production. Then we have like some other cases that are more related with bugs. And for example, we had this issue, we were seeing that for a player, we had like, for the same time stamp, we have like 4 recommendations that were different. And we just didn't know, or it was very hard to know which one was the right one that was actually used by the player, because sometimes like the service log, we have several servers, and then we have like two inference serving at the same time. So that's problematic. And then we have lots of bugs sometimes in the code. That's something that everyone has. And the key thing here is what I mentioned before, like having unit tests. And we also have not only unit tests, but we have our pipelines running in the development environment. So I mean, of course, it doesn't have production data, but we have like simulated data. So all our pipelines can run end-to-end in a development environment. And most of the bugs have been caught in the development environment, so there are not many bugs come to production thanks to that. And finally, we have the operational issues. So the increase of complexity is one of them. So having these kind of models in production make it far way complex for the game teams to understand what's going on in their game. So that's why we need to really prove that there's an extra leaf for a specific use case in order to implement this in production. Then we have like what I call the A/B testing cadence. So the game teams operate really fast. Live operations, it moves really fast. And they want their A/B tests have to, usually they kind of take, it depends on the game, but 2 weeks, let's say. And then, like when you put a model like this in production, the first thing that does is starts exploring. And usually we have epsilon greedy, so it's random exploration. So I mean, if you only have 2 weeks, like the first week, most likely the model has not really just converged or learned anything. So I mean, in the other week, I mean, you can only take the results from the second week, but it's not going to be that meaningful. So you have to maybe talk with the games. Maybe we need a longer period for this type of tests. And there's a different way to analyze them because there's an exploration phase. So it impacts a lot how they operate, because they are running a lot of A/B tests all the time. So you need to also find a slot in their A/B testing calendar to test these things. Then the other plan is to find the killer use cases. What are the best things that the game team can recommend to the players? And that's up for the game teams to decide, but that will impact the model's performance a lot. And finally, it's also incorrect usage because we put this kind of product out there, and sometimes they need our help to understand what are the main use case where this can help, because sometimes they kind of misuse it or they don't have into account that the exploration phase or they kind of create use cases that maybe are not the best fit for this reinforcement learning use case. Maybe for some use cases, it's better to do just a supervised model for that specific case. So those things have to be taken into account too. And finally, I also want to mention that teams are a critical part of this because sometimes, I mean, we have seen in this conference a lot of platforms, a lot of vendors, but sometimes, I mean, if you already have something in-house and you have the teams that can help you, maybe it won't be that fast, but you can, if you have like good practices, then you can get there, even without like tooling specifically for that use case. I mean, for example, you can have like this kind of MLOps good practices, and you don't need a tooling for that. I mean, even you can have like a good tool, and if you don't follow good practices, it will be useless. So I think for me, in my opinion, the teams come first, and then if you have a good team, you can even like work with or without the tooling. And finally, I started the talk saying like, does reinforcement learning increase joy of players? Can it do that? And I guess my answer is most likely not. I mean, the reinforcement learning is not the one adding joy to the players. It's the game teams. The game teams are artists, have like great content. So they do add joy to the players. They are working hard on keeping players engaged, keeping players keep playing the game excited. But what reinforcement learning can do is to kind of try to find the best fit for those new content that they create so it reaches the best people. So it's kind of a yes-no answer. So it doesn't create kind of joy by itself, but it can help like that the content that the game teams create reaches the correct audience. And just to finalize, I want to also to mention that reinforcement learning in production is hard. Don't underrate it. If you're going to start a project, it's going to take time. But I mean, without MLOps good practices, it would be a nightmare. So you really, I mean, if you start a project like this, you need to really start like do a good plan and do it properly, like good practices, because if not, it will get very messy. And that's everything I have. But if you have some questions, I will be around. But you can also ask them now.
Thank you so much for your insights. One question, you talked about the real-time inference and the people being offline. Have you thought about putting your models like on device? So when you download the game, I'm also downloading the model and use on-device machine learning?
We of course considered that at the beginning of the project, but I think that's very hard. I don't have a lot of insight about that, but I haven't seen like people doing that in gaming at least. But I'm really interested in that. I think that could be in the future, like that could be a really good option. But yeah, we thought about it, but the complexity would have been much greater.
So you mentioned about the killer use cases. So what do you insights of like, what will be the characteristics of the use cases for reinforcement learning? Do you have any insights?
So specific to gaming or in general?
It could be general or it could be specific to gaming.
Yeah, so I could say like in general, I mentioned the difference between contextual bandits and deep reinforcement learning, so my recommendation would be to try to go with the simpler first. So contextual bandits are easier, so sometimes you don't need the extra complexity of deep reinforcement learning and that sequence of actions. So I think what it helps me to understand what's a good use case for deep reinforcement learning is to think about this sequence of actions. Does it add value, this sequence of action, or is it something, maybe for example for conversion offers? Maybe, you know, like just you get instant, is it converted or not, then there's no added value of deep reinforcement learning. Contextual bandits can work just fine. Of course, deep reinforcement learning adds value on top of that, but if you don't have anything, I would start with contextual bandits, right? And with gaming specifically, it's a hard question. I mean, most times I'm just talking to them and asking, like, what do you want to achieve? But I mean, the ones that come with the actual use cases are the game teams. So they are the ones that know what their players want and what they want to give it to them. So I learn from them. And I just tell them, yes, this is really interesting. They surprise me and they, oh, this is great. I mean, and I think we can test this, yes. But you know, like the ideas come from the game team, not from our team.
Hi, great talk. I really enjoyed the tools that you mentioned in the research phase. A question on that part. When you are doing research, and as you mentioned, it's really hard to beat the rule-based systems. So what was the confidence at that time to invest in all this tooling and the MLOps best practices when you don't know whether at the end of the line it's going to be going into production or even sort of an idea that's going to get more traction? So when you were beginning at the research phase, is it just generally good to have this tooling for all the projects and then go on, or did you have some insights or initial studies that you thought this is going to be promising?
Yeah, that's a good question. And what I would say is, like, I mean, all these kind of MLOps good practices, we have them from this project, but we have them for more projects. So it's not like a single effort just for this project. I think the good idea is to have like a common structure across your data science and ML engineer teams, so you share it across the projects. I think it reduces the flexibility of your team, but I think flexibility sometimes is overrated. So, I mean, it's far more useful, like you give them some flexibility, but then, like, for example, these tools I mentioned, like MyPy, Black, maybe you don't want to use them, but then we make it configurable for projects. So in this project, we used all of them. It's possible we have a in-house command line tooling built on top of Poetry that helps us kind of create, like, I mean, out there, for example, people use Cookie Cutter also for template in the projects. So I mean, we do have like common tooling for all our projects that we try to make it configurable, but we try to be a bit also opinionated. So we share the same practices across projects, because we don't want to end up in a way like when you go into a project and then you need to relearn how things are getting into production, how do I deploy, how is the CI/CD pipeline. So we try to share like the main structure of CI/CD pipeline across projects, the kind of same ways of working with the projects. So we are trying to do that, and that's kind of like, I think it pays off in the long run, like it's not only for this project.
Thank you.
So you mentioned about data scientists and engineers. They work together, and then we have this previous panel and the opening panel. So the panelists were talking about data scientists and machine learning engineers. They work together. So can you, how is your company, how do they work together? So are they working in silos, or do they have like clear responsibilities, or they work like a cross-functional team?
Yeah, so I'm part of the machine learning and data engineering team, so I work very closely with data engineers. And we have then a different team in business intelligence that are the data scientists. So I mean, our team is not very big. We are like 10, around 10. A bit more, I think, but we are combined machine learning engineers and data engineers, and then the data scientist is in another kind of unit, and then we try to collaborate. So it's always about, we want to kind of bridge the gap between, it's not only about data scientists, also in gaming companies we have a lot of data analysts also. So you want to bridge the gap between data analysts, data scientists, machine learning engineers, and data engineers, and the way we do it, we work with epics. So we create an epic team, and we try to put put people from different teams in this kind of epic team. So in this project, that's a great example. So as you saw, there were front-end development. I mean, we don't have in my team like front-end developers. So I mean, we just ask for the kind of the front-end development team, can we get a resource for this time, for this project? And we create this kind of cross-unit epic teams that work on some project for some specific time, and it doesn't need to be, the resource doesn't need to be allocated for all the time. It means I just need a front-end developer to do this feature for this time, and then they just do their tickets, and then it's done. But we try to create these kind of cross-functional teams for project-specific things that provide some business value.
Thank you.
So, hi, wonderful talk, really enjoyed it. So, My question is around the testing phase. You mentioned some tool, PyTest, but it's not about the tool, it's more about conceptual testing. So when you are testing the feature itself, and especially the reinforcement learning, not the A/B testing, but just the feature itself, what are the tests or automated tests that you have built in within the pipeline?
Yeah, so yeah, I agree. It's not about the tooling; it's about the actual which test do you make. And that's, I mean, we try to we work a lot with pull request ways of working. So then, you for example, with data scientists, you see a pull request from a data scientist, they create a new method, and they don't have the unit test. So we try to be transparent there. Like, can you create a unit test? And then that's very helpful. And then what unit test to create in reinforcement learning specifically? That's a hard question. Because we unit test specific parts of the code. Like, for example, if you want to create from a categorical value an embedding, then you maybe test that things don't break, but you don't really test that the model works in unit tests, right? So then we have these flows where we test that, for example, the model, the whole feature engineering of the model is working fine. And what we have is dummy data. So we have dummy data that for really simple cases, the model, it's trained correctly and something sensible, and then we also deploy it and SageMaker in the dev environment, and we see that it predicts something. So we have that live, always in the dev environment. So whenever we do merge something in develop branch, then it automatically goes there, and we see if something breaks. So that's how we catch most of the issues, having this all the time. Of course, it adds more cost because we have everything replicated in the dev environment. But on the other hand, it helps a lot. It doesn't help you to catch a lot of issues. Some issues with data. If data changes, then those issues hit production, of course. But it helps us to, when we get an issue in production, then we can make a unit test if it's possible. If it's something small, like about some field that we thought we had this format and then it has changed, then we can make a unit test for that, maybe for the processing function. But not everything can be tested, of course. There's so much you can test. Thank you.